So what we need to do is write an actual script to control the movement of the camera. So first of all, we're going to make sure it's no longer a child of the player. So we'll drag it back up to there. And then we're going to go into our scripts folder and create our second script. So we'll right click in here, go to create, and then C# script. And we're just going to call this one our camera controller. And again, remembering that when we create a script within Unity, we don't want to have any spaces between the words, because that'll break everything completely. And we want to make sure whenever we start a new word, we start with a capital C, so that Unity knows where the break in the name of it should be. So now now that we've created it, we're going to double click on it and open it up in MonoDevelop. So we'll give that a second. There we go. Okay, so now, as I'm sure I mentioned previously, we've got this kind of error that occasionally pops up depending on which system you're using and stuff like that. So we just want to hit the OK button to get rid of that. But at the most basic level of our camera controller, we want to tell it to follow our player. So we're going to need to know what thing it is that the camera should be following. So the first thing we're going to do here is just say public, and instead of being specifically about the player, because we might want the camera at some other point in the game to focus on something else and move to some other position to show something or anything like that. So we want to say public game object, and we're just going to call it target. So rather self-explanatory. A game object is just a type of variable. It's just any kind of object that exists within the world of our game. So here we're just referring to whatever we're going to use as the target of our camera. So we'll just save this, and we'll actually just go back into Unity here, and we'll go to our main camera, and we're going to attach that script to it, and we're going to do it a different way than we did last time. We're going to drag our camera controller over add component here, and when we've got that little plus symbol, we can drop it, and then we go, the script is attached. So we've got our target, and we know at the moment the target we want to use is our player. So we'll just click on our player and drag it into there, just like the way we want it to. So now we've got our target in place, so we can actually do some stuff with it. So in our update loop here, which as we discussed before, our update loop is what occurs every instant and moment of our game. So our update loop, we want to tell it here to follow the player's position. So we're going to say the transform dot position, which again, as we discussed previously, our transform position is attached to every single object in the game, and by default Unity knows that whatever object this script is attached to, that's what we're getting the transform position of. So we're not referring to the player here, we're referring to the camera, because that's what we're attached to. And the position that we want the camera to be at is, just as an example, we're going to say we want the position of the camera to be, if we wanted it to be directly at the same place as the target, we would just say our transform.position is equal to our target dot transform dot position. So what we're saying there is the target that's up here, we want to go to the transform part of that, so on our player, the transform component, and then we want to go to the position of that. So we'll just hit our semicolon, and just as an example now, we'll save this and go in here, but this is actually going to cause an error for us, so we'll just take an example of what that's going to look like. So we'll hit play once that compiles down there. No, not pause, we'll hit play. And when our game starts going, what we actually end up with is a completely blank screen. And the reason for that, if we just pause it here, is because the camera, the Z position of the camera is 0, and the Z position of the player is also 0, and therefore it doesn't know what to do. So if we just stop the game here and go back to our camera, we'll see that by default the camera Z position is set at -10, and that's so that it's a little bit back so that it can see anything in front of it. Whereas if it's on the exact same line as anything, then it doesn't know where to look. So we want to make sure that we're not making any changes to that Z value. So if we go back into here, instead of just using the target.transform.position, we're going to again make it equal to a new vector tree. So we're going to need an X and a Y and a Z value. Now obviously we're going to want to follow the target on the X-axis for sure, because we want to make sure that as the player moves forward in the world, we're following along with him. So we're going to say new vector tree, and the first x value will be our target dot transform dot position dot x. So we know we're following along with the position of the player in the world. So now on our y value, what we're going to want to do is just keep the camera at the same height. And what that means is, if we go back here, our camera will always look like these objects here are on the ground, and that as I said, it looks like they could be going to infinity, but as we know, they're just barely going below the bottom of the screen. So now we want our camera to stay at the same height, so that when the player moves, he moves up and down within the world, but he moves left to right with the camera. So what we'll say here is, instead of our target transform position, we'll just use the current transform dot position dot y. So that's the position of the camera. And again, we want to use the z position of the camera, because like we said, we don't want to make changes to that, or else we'll end up cutting through the screen and we'll end up with a completely blank screen again. So we want to say transform dot position dot z, like that. Okay, so now at a very basic level, if we go back into here, wait for that to compile again, we've already set up our script so that it knows what target it's looking for. If we hit play like this, what we'll see is now we can move left to right and the camera will follow along with us just nicely. If we jump up in the air, our camera stays perfectly level, but now we didn't lose track of seeing this platform. We're able to see everything in our world, and we can just kind of jump around and have our little bits of fun like this. But it's very the fact that it's following exactly with the player, it's kind of a little bit disconcerting. So it's also a little bit weird that our player is exactly in the middle of a screen. If you look at lots of other platform games, a lot of the time the player won't actually be in the middle of the screen. We want to be able to see a little bit more ahead of us as it is. Now, just also the way we have the window set up here, it's incredibly wide. We know that our game, when we're playing an actual real game, the screens that we use to look at stuff are never that big. If we go up to free aspect up here, the most common kind of screen size at the moment is 16 by 9. So if we hit 16 by 9, it creates these little black bars to the side. This is basically what a normal kind of HDTV kind of shape screen is, or a normal kind of PC monitor. So now we see we've cut off the edges to the side, and we're kind of losing a lot of what we can see ahead of the player here. So if we jump, we don't have much that we can see ahead of us. So it'd be nice to be able to look ahead of the player a certain amount to see within the world. So we can easily do that back in here. We want a certain amount that we want to move the camera ahead of the player. So we'll create a new value up here. We'll create a new public float that we'll call it follow ahead. Follow ahead. So this is the amount that we want the camera to follow ahead of the player. And what we can do here is we want to follow ahead of the player, but we also, if we change direction, so we're looking to the left, so we're moving to the left even, we want to follow a little bit behind the player. And we know that the only way that we can tell whether the player is facing left or facing right is based on the scale of the player. So what we can do is actually check the scale of the player. So we can say if the target dot transform dot local scale, because we remember our local scale is what we changed to determine whether we're flipped left or right. So if the local scale dot x, which is the x value, or which is the moving left to right value, if that is greater than 0f, then we know that we're facing right. So we can add some curly brackets here, and we can say our transform dot position. We could add on, or for example, actually what we could say here is our follow ahead should be a positive number. But what we want to do is just kind of add, we want to create a new target basically that we want to be working towards. So what we're going to do is back up here, we're going to create, rather than being public, we'll create a private vector tree. And as we've seen with when we're creating new vector trees and stuff like that, a vector tree is just an object with tree values, so an x, y, and a z value. So we're creating a new object here that we're going to call our target. And down here, what we can say, oh wait, no, sorry, we don't want to say target. We've already used target. We want to call this our target position, which makes a little bit more sense. So our target position, what we're actually going to do is, instead of setting the transform.position, we want to use a target position. So we're going to change this to be our target position. So that's a vector value, a vector tree value even, sorry. So our target position object that we just created, from now on, that's going to be what we're setting here. So at the start of our update loop, we're setting that to be what our, basically the center of where the target is, but not moving up and down. When we want to add a little bit of following ahead, here we're saying, okay, if he's facing right, then now our target position can be equal to a new vector tree. So now the x value, if we're facing right, we want to add on the follow ahead. So we'll say our current target position dot x plus follow. If I could type things, follow plus follow ahead, and we want to leave our target position dot y the exact same, and our target position dot z the exact same, and then hit our semicolon there like that. So now what we're doing is, at the start of our update loop, we're setting the value that we want the camera to move to. Then here we're saying, okay, we want to move it ahead if we're facing right, but if we're not facing right, else we're either facing right or we're not. So we know that if we're not facing right, then we have to be facing left. So then we can say, within this, we can copy all of this stuff the exact same, paste it in there like that, and instead of adding the follow ahead, this time we're taking away the follow ahead. So now after this little if else statement here has been run through, now we know that our target position is where we want the camera to move to. So now after that, we can simply say, now our transform dot position, which again is the transform of the camera, which is what this script is attached to. We can say our transform dot position is now should be equal to our target position. So we can save that, and we can go back in here, and again, as it compiles, we should see that now our camera will follow ahead or behind the player based on which direction we're facing. So if we hit play, now if we move to the right, oh, we didn't actually set a value, that's why nothing's happening there. Go back to our main camera here. We can set our follow ahead value, say we set it to about 5, and we'll hit play. So now we can see we're seeing a good bit ahead of the player like this, and if we turn around to look the other way, we're now able to see a good bit kind of behind the player like this. But again, much like we had when we made the camera a child of the player, we're getting this kind of awkward flip between both of those. It's a very kind of sharp and jagging. It kind of almost looks like we're teleporting around the level, and obviously that's not what we want. So we want the camera movement from area to area to be kind of smoothed out, and also we want the camera to kind of gently move into position within the world. So what we'll do is, back in our script, we're going to do something a little bit different. We're going to use a thing called a lerp, which will kind of gradually move our camera within the world.